Welcome. So in this conference, which is mostly centered on another monitoring solution and its forks and different solutions around it, I'll be presenting about something else, a different monitoring solution called Zabbix. And today I will mostly drift between three different topics. I will give a brief overview of what Zabbix is for those who might not have that good experience with it. And actually, I was here in the OSMC 2 years ago, and 2 years for Zabbix, that's actually quite a lot. So I'll also try to give some information about what has changed for Zabbix over these 2 years, which should provide some information for those who might have previous experience with Zabbix, as well as give some information about how rapidly Zabbix is developing, what new functionality is appearing, and at what rate. I'll finish this with slightly not so serious part about the, let's say, less common uses of Zabbix, how it can also be adapted in some non-conventional monitoring. Before I continue, I'll start with the traditional question. So who has heard about Zabbix? That's almost everybody. That's impressive. That's better than 2 years ago. So thank you. Who is using Zabbix, maybe? That's much less impressive. So that's like, what, maybe 3.5 people. So I'll give you some information so you can decide on maybe you can increase that count here. So just a brief overview of what has changed, large significant changes for Zabbix for the last 2 years. Something that was brewing for almost 3 years. Our current stable release is Zabbix 2.0. It came out this year on May. Zabbix 1.8 was the previous current release that was out in 2009. So it took really a long time for us to get 2.0 out of the door. It's really great, and I'll give some overview of what's offered there. We also, during this time, released 13 maintenance releases for the 1.8 series. So for the long-term stability, we are still helping users who are staying with the previous stable release, even though it's been quite a while since it first came out. Zabbix is becoming much more popular. We even have had 2 conferences specifically on Zabbix only. That's in Riga. It's not too far from here. They happen in September, so they do not clash with OSMC. We specifically picked the dates so it wouldn't really conflict with this one. Recently, Zabbix opened a branch in Japan. So Japan, I'll mention that a bit more later, but Japan is really a place where Zabbix is extremely popular. So what Zabbix is, the age of it, and what it offers. Zabbix was started to be developed in 1998, so that's quite a long time ago. Actually, it's not a recent solution. I'm not coming here to tell you about the project I started last week. And the first public open source release came out in 2001. So counting the official publicly available releases, Zabbix will be 12 years old next year in April. Again, we will have some party in Riga. Most likely in September again, so everybody is welcome. It's not really a long trip from Germany. I'll probably start with one very important thing, which is important for a large amount of our users and customers, and also which is important for me personally. And that is that Zabbix is fully true open source solution, which means that everything you get on the SourceForge, that is all there is. We don't have proprietary add-ons, enterprise versions that you have to purchase to actually do some real monitoring or configuration work. Everything is fully open source, GPL version 2, nothing closed source offered by Zabbix. Which is maybe in a contrast with some other solutions, which might have something which is like a leader into the commercial product, which will give you something for free, and then they will ask you to come with money to actually do the work. We do not believe in open source being used as a leader into the proprietary solutions, so we do not do that. We have full open source thingy. This might even be some sort of cultural difference I've heard between Europe and the USA maybe, where in Europe you will mostly see open source products and then services offered on top of that. In the USA you will see open source only used as the leader into the proprietary products. And that gets muddied even further, and at some point you're not sure whether you just get this open source small piece that should get you into buying some other software, or maybe somebody says that it's a shared source, and then the word source becomes unclear at all, even if it's prefixed with open or not. So what does the Zabbix offer? It offers a fully integrated solution, so all the pieces are tested together. They are tested as a solution, not as individual components. And of course, we are offering the first thing that everything starts with. That's data retrieving. That's actual monitoring, data gathering. I'll expand on this quite a bit more in a moment. We're also offering a built-in historical data storage. So everything you gather, that is already stored by default. You don't have to think about that separately. It's available as the part of the basic product. We're also offering the official web-based front-end. It works with the most modern web browsers. It offers full configuration capabilities, monitoring capabilities, and I'll show some hopefully more or less shiny pictures a bit later as well. And of course, built in the product are all kind of other functionality, including alerting with escalations, discoveries, all kinds of them, and lots more. I'll expand on some of these later today, but I will not have time to talk about all the functionality, of course. The main components that Zabbix consists of are the Zabbix server. This is the heart. This is the real core of the Zabbix system. This is the one doing all the hard work, having all the logic, having all the knowledge, controlling everything. Then there's a database, because all the configuration that Zabbix has is stored in a database. It's a Zabbix backend. And we have the front end, which is the graphical part, which is communicating with the server, with the database to sort of tell server what to do. These components, you can run them on a single server. You can distribute them on separate systems. That's fully up to you. Depends on your environment, on what systems you already have available. If you have the centrally available database, you might want to reuse that for the Zabbix database as well. Another very important thing that Zabbix offers is a native agent. It's available for pretty much all the platforms that are still out there, and for some which are maybe not that much out there anymore. It offers quite a lot of built-in data gathering capabilities. So using the agent without any extending, without any scripting, you can gather the CPU statistics, file system process statistics, the check file sums, gather checksums on files, and so on. Zabbix agent is only obeying what the server tells it to do. So all the logic is on the server. Zabbix agent is fully controlled by the server. We do not distribute the configuration to be controlled by a large amount of people. Very important part actually is this native thing, because it's native code running on the platform. We're not using any interpreters. There's no Java to eat the precious memory on your important servers and so on. And it's the same agent code on all the platforms, of course with some platform-specific things, but the main things that agent has, we're not re-implementing it for a platform. It's an all common code base. Getting a bit more technical about how the agents work, and so that we can use the same terminology at least when talking about Zabbix. Zabbix agents can operate in two modes. They can operate in the passive mode, and when we talk about passive and active in Zabbix, we're talking from the agent perspective. So we call the agent either passive or active. And the passive agent is the one which is just sitting there and waiting for the server or any other component to connect to it. So server connects to the passive agent, asks for some data, gets back the value, and it's happy after that. In the active mode, agent starts by connecting to the server and asks, what should I do? Server replies by sending a list of things agent should be doing. How often, how exactly, what data should be gathered. Then agent goes away, starts gathering the data. Once it has collected some values, it will connect to the server and send these values to the server. If it has collected multiple values, it will send them in a single network connection. Zabbix agents use fully IANA registered ports, so these are officially Zabbix ports, 10050 and 10051. Nothing else should be using these ports. You should not conflict with something like Windows Dynamic Port Range or anything else. These should be safe for you. Obviously, Zabbix also offers lots of different agentless methods for data gathering. One of these is various TCP checks, starting with simple TCP port checking with some basic service checking and extending further. That also includes, of course, SNMP. That's something that already has been mentioned today in some talks, and we'll, I believe, have quite an extensive talk on that after this, or more like after lunch. Zabbix also natively supports IPMI, so it's possible to query IPMI devices. You don't need any scripts, any interpreter layers, anything else. That's fully done by the Zabbix server directly, so the performance should be pretty decent even if you are monitoring a large amount of IPMI devices. And And there's also support for executing SSH and telnet commands. So if there's any device that you cannot monitor in any other way, then you can do something like this, which is not that great for configuration reasons, for performance reasons. We would suggest using Zabbix agent just because it will perform much, much better, but that functionality is available. And of course, for SSH, there's built-in native support available both for password and the key authentication as well. And again, all that is built in. That is the C code doing this, so performance, even if we are running a really huge amount of checks, that should be very, very good one. Zabbix also offers several built-in advanced methods for data gathering, and one of these, this is a new one since we last met 2 years ago. It's a pretty great one, and it allows to calculate some value out of other already collected values. So you can grab some things, do some mathematical operations on them, store the value as any other normal item, which can then be graphed. You can then check the values there, whether they are normal. You can even reuse another in another calculated item. So do all kind of magic in Zabbix itself. These calculations can be very, very powerful. I will expand a bit on the available functionality when I'll talk about how you can define what a problem is. And of course, all the calculations happen without querying the original devices again. Another method is aggregate monitoring. So if you're monitoring a cluster or a server farm, then you can check something on all of your systems, like the total disk space on all of your file servers, or the average queries per second on all of your database servers, and that will be calculated by the Zabbix server fully automatically, just based on the hosts which are assigned to a single group. There's lots more about data collection. For example, one new feature that we implemented in Zabbix 2.0 is support for nanosecond resolution for all the historical data that Zabbix is gathering, which was requested by our Japanese users. But I could probably spend a few more hours just talking about data gathering, so let's continue with something else. And that's a feature in Zabbix, or part of functionality in Zabbix, which is extremely flexible. And it's defining what a problem is. So instead of the problem definition being attached to a single data source, to a single check, or in the Zabbix language, it's called an item, these are separated. It's a configuration entity called a trigger. And the trigger has an expression where you define with the specific syntax what a problem is. This is extremely powerful. You can start with very simple things, like you can check whether the last value is above or below a specific threshold. Most people who are using Zabbix, they use something more advanced. A very common approach is, for example, to avoid flapping. We are not checking only the last value, we are checking the minimum, maximum, or average over some time period. So instead of flapping, once we see one CPU load value spiking, we can check that it's actually staying high for the average of 10 minutes or half an hour, or whatever is the time period you would like to check. There's a really large amount of trigger functions available. You can limit based on days of week, of dates. You can check for strings in different values returned, and all that processing is fully done centrally by the Zabbix server. You can also check values from multiple items in a single trigger, which means that you're not limited to checking things in isolation. You can correlate them directly there in the problem definition. One example might be that we could be checking user session count in correlation with the CPU load on some system. If the CPU load is high, but there are no users on the system, then it's a problem. If there are users and the CPU load is high, then that might be considered normal. Even better, we are not limited to checking values on a single system only. We can correlate values from any amount, any number of systems. So if there's a web server which is serving pages from an NFS server, we could correlate the load of the NFS server with the web page response time. If the NFS server is slow, then it's totally okay for the web response to be longer as well. Another thing about the problem definitions in Zabbix is that we are offering built-in 6 severity levels. Of course, you're not required to use all of them. If you decide that in your environment everything is high in disaster severities, that's it. You just use these 2 and you ignore the rest of the 4 of them. And by the way, in Zabbix 2.0, another new feature is that you can even rename these and change the colors just by a click-through interface. You don't have to hack anything if you like to name something like, let's say the last one could be panic, for example. And that's a very, very easy reconfiguration. Zabbix also offers a built-in templating system which should help to configure large environments much more easily. A template will contain things which will define what should we monitor, and it will contain information about what we should alert on. Along with that, also some visualization options and some other configuration data. So these templates then are assigned to individual monitored hosts, which allow us to, for example, modify some specific feature of MySQL monitoring, and that will be applied automatically to all the hosts. The templates can be nested, and they offer also variable replacements in several different aspects. So this is a very, very flexible part of Zabbix configuration as well. Now, another new feature in Zabbix 2.0, and this is something many people are really happy about because it's implemented both in a very efficient and nice way and also in a very flexible way. It's something called low-level discovery, or just LLD for short. And it allows to discover entities on already monitored devices. For example, the Zabbix agent already offers two built-in methods of discovery. It offers discovery of the mounted file systems. So if you have lots of systems with different mount points, configuring that in a large environment might be a bit problematic. You might resort to some scripting to automate that. That's not needed with Zabbix. You can just tell Zabbix to discover all the file systems and then monitor something like free space on all of them, monitor free inodes on all of them, anything. And it's also available for network interfaces. Again, if you have lots of systems, different amount of network interfaces, this will be very helpful. No need to implement all kind of manual layers. Zabbix agent will just do that for you. For those lucky enough to monitor Windows systems, you might have seen that the Windows network interface name can depend on the driver, firewall, antivirus, day of week, maybe something else. I've heard that some rumors that latest versions of Windows have stopped doing this, but I've not seen that myself. So again, Zabbix agent will just discover all the interfaces no matter what their names are, and you will be able to monitor anything on them. Incoming traffic, outgoing traffic, anything else the interface will offer. This is available built in the Zabbix agent. Another mode where the LLD comes in is the SNMP, and very common approach, of course, is to discover all the interfaces on a switch, especially on the devices which will reindex them seemingly randomly. So this is now possible in a very flexible way in Zabbix as well. We can, of course, discover all the interfaces and tell to monitor the if in octets, if out octets, errors, discards, opper status, alias, anything. But it's not limited to interfaces, just any SNMP table. If you are exporting process lists, if you are exporting file systems over SNMP, you can just discover all that using Zabbix SNMP support and monitor something for each entity that is found. This is done fully by the Zabbix server. So again, there's no scripting involved, no different intermediate layers. And the great thing is that this is also exposed to users. So you are able to push custom discovery data to Zabbix one way or another. Maybe this is easier to explain with a more specific example. So if somebody would re-implement the built-in agent file system discovery, you would send a JSON fragment like this to Zabbix. So when we implemented the file system discovery for Zabbix agent, initially we only discovered the mount points, which seemed to be nice at first, but then we started monitoring all things like procs, sys, TMPFS here, TMPFS there, and a bunch of other things. So we extended this to also return the file system type. So you're able to filter by file system types and only monitor or exclude what you need or do not need. So this is syntax that you would send to Zabbix, and if you'd like to discover something that is more specific to your environment, let's say you would like to discover databases, or maybe you have a custom application which has some custom entities, maybe it has some shards or anything else. You just send something like this to Zabbix and tell Zabbix to monitor something about each entity that is included in the JSON. Really easy, really nice, really flexible. We spent actually a lot of time on designing and redesigning this feature because it was lucky enough to be implemented sometime before the 2.0 came out. So we had quite a lot of user feedback while it was still very, very flexible and we could break previous compatibility. Or just improve it. And one thing we did, which was not available initially actually, is that when an entity disappears, Zabbix discovery will of course notice that. But what will it do with this entity is fully configurable. You can choose for how long the entity will stay. And if the entity has disappeared, Zabbix will even give you a warning on the front end, on the bundled graphical front end, telling you that, hey, this interface or this file system disappeared. We will remove everything about it in this long time, and that will be at this date, at this time. So you have, like, in this case, 3 hours to salvage the data if you really, really need it. Of course, the time period for how long the entities are kept, it's configurable. By default, Zabbix will keep data for 1 month. Most people will not need it for that long. Users really like it. There's hardly any user in 2.0 who is not using low-level discovery. So that's a very, very major reason for existing Zabbix users to migrate from 1.8 to 2.0 as well. Another thing that we implemented in the last 2 years is automatic inventory gathering support. So Zabbix for a long time had inventory support, but there was no easy way to automatically gather this data. You either had to implement some API layer to push the data or integrate with other systems, or maybe input it manually, which many users actually did. So now in 2.0, Zabbix can automatically gather inventory data. And just some example of the data that is included and available with the Linux agent natively. You can gather all kind of hardware details like the serial number, vendor, model, probably some other things. You can also gather information like the CPU frequency, CPU vendor, CPU model, if you'd like to have statistics on your whole environment about, let's say, which vendors are providing your CPUs. You can gather the list of PCI and USB devices, which is simplistically the output of LSPCI or LSUSB. But again, that is fully centralized, fully automated, and all gathered in a specific Zabbix configuration. MAC addresses of all the interfaces, again, all that natively supported by the agent. All kind of details about the operating system, about the architecture, and also it's possible to get the list of the installed packages if you'd like to monitor whether some package is installed or is not installed in all of your systems. Currently, Zabbix agent supports RPM, DPKG, SlackPKG, and Pacman from Arch Linux. So 4 packaging systems. We might consider adding support for more, but currently these seem to be enough. And of course, same as with nearly any other functionality in Zabbix, you may run any custom command and put the results in any field of the inventory. So it's very flexible. That's another feature that I really like how it was implemented in Zabbix. You can just put anything in any inventory field and then produce some statistics, how many systems have it at each value. Another significant feature in Zabbix 2.0 is ability to monitor hosts with multiple interfaces without doing some trickery magic or adding multiple hosts manually. You can add multiple interfaces for a host. You decide what is the interface type, and then you choose which service should be monitored on which interface. So you could say that I'd like to monitor this TCP service on this IP address, this TCP service on this DNS name, then I'd like to use another interface for SNMP something, and then yet another interface on the management network for IPMI. Zabbix will, of course, automatically distribute everything through all the corresponding interfaces, and all this will be done with a single host, so everything will still be aggregated on a single system in the Zabbix configuration. Of course, the other thing is the important part of any monitoring solution, and the long-time supported built-in methods in Zabbix for sending messages include email, SMS with a direct GSM modem support, and also Jabber or XMPP. The direct GSM modem support is actually fairly useful because it wouldn't be the brightest idea to send an email about email server being down. So it's something I usually suggest users to at least consider. Very powerful module in Zabbix is something that's devoted to escalations. This is probably maybe not that easily to read down there for some of you, but it says something like that emailing to the first level tech support. That. So there might be a very, very simple email sent to the first level tech support to inform them that there's a problem. If they do not fix the problem, we probably would like to escalate, so we can escalate to the second level tech support. If the problem is still not resolved, we might want to bug them with an SMS. The problem is still there after a while, so now we would like to escalate to management, but now we can hook into another functionality in Zabbix, which is called acknowledgements. You can acknowledge a problem by entering a message, then everybody will see the username, timestamp, and the message that was entered. And in the escalation, so we can actually check the acknowledgement status of the problem. If somebody has acknowledged a problem, we do not escalate. So this is a very, very powerful motivator for people to use the acknowledge functionality. They know that if they will acknowledge, then the escalation to the management will not happen. If the problem is still not there, if the problem is still there, if it's still not fixed, we might automatically try to restart the service using the built-in native capability over the Zabbix agent. And again, we would probably do this only if the problem is not acknowledged, because if it's acknowledged, somebody is working on it. We really don't want to go in and just, hey, restart the service while somebody is trying to fix it. Then we would send an email to management, and we would ignore the acknowledgement status, which would mean that if somebody acknowledged a problem somewhere there in the first few steps, the escalation to management would be delayed. We would not just completely silence and hide the issue. Problem still there, we are restarting the server via the IPMI. This is also fully built-in integrated support, same as monitoring over IPMI. Zabbix has remote IPMI commands built in. So you can just reboot, power on, power off systems easily. And finally, we might toggle the UPS port using SNMP set commands. That's not a very common thing to do, but technically fully possible. Assuming anybody nowadays actually implements a working SNMP set on UPS devices. I haven't really read any manuals about this lately. Of course, all this is extremely configurable. You do not have these levels that you have to choose from. You just add these actions, you add these steps to escalations, and you choose what the duration is, how many steps, what will they do. You can start by restarting the server and then sending a message. That's fully up to you. This module is also very powerful with the conditions, so you can choose who and when should be receiving a notification. For example, maybe only the DBA should get a message about the database being down, and maybe you want to send a message to email only during the working days, and then on the weekends you only want to send SMS, or any other combination of these. We may also include all kind of useful information in the messages. So if we are monitoring the mail queue on a mail server, we could include the current mail queue length in the message that's being sent out, hopefully not over email. We can include serial numbers. So maybe you can already order spare parts without even opening any other inventory system. You already have that in your email. You know which part should be replaced. And the messages may also be customized per recipient. So maybe if we are sending message to technical people, we are sending all the technical information, serial numbers, last values, the CPU loads, smart status, anything we can decide to. When we are sending data information to management, we would hide the technical information, not to confuse them. But we may include in the messages something that will inform the person who was notified before, when exactly, how exactly, and whether that was successful. This is a feature when we show this to technical people, when we show this to management, they go like, wow, that's a really great feature, we should use this. When we show this to the technical people, they go like, oh, we should hide this from the management. Nevertheless, I think this is a very nice feature. It provides a really great overview of what was done or what was not done with the problem since it happened. The bundled frontend that's included, this is a very important thing. Again, fully open source, fully included, fully integrated, fully supported. It offers three main features for you. That is the real-time monitoring, so you can just see the values. There's a built-in visualization, different types of these. We will look at some of them. And it also is the official configuration interface with which you perform changes to decide what should be monitored, how exactly, and what should be done when there are problems, and so on. The Zabbix frontend has a user and user group concept, so you can assign permissions. Again, only DBAs will see database servers, maybe only networking people will see network switches, and so on. Zabbix frontend has some theming support. There's also localization support, so it can be used in different languages. We have lots of translations. Some of them are in better state, some are in worse. The German translation of Zabbix frontend, I looked last night at 3 o'clock at night. It was at 86%. So it's not perfect, but I think it's pretty usable. Currently, it's, by the way, done by a person from Vienna. So if anybody would like to join that part, I'm sure they would be happy for German help as well. There's a huge amount of front-end improvements over the last 2 years. I'll mention only the really more important ones. Especially the usability has been improved, which was a long time complaint about the Zabbix frontend. It was there, it was very nice technically, but the usability and discoverability was, especially for new users, maybe not so easy. So now it should be notably easier. When I talk about the big features in Zabbix 2.0, there is one which whenever I mention to people, they're never unhappy about it, they're never indifferent about it, they're always happy about it, especially if they're involved in any kind of web development. And this feature is that with Zabbix 2.0, we dropped the MS Internet Explorer 6 support. Good riddance. This actually not only helped us to not care about the problems anymore that were arising with it, which was like constant stream. It also allowed us to simplify several things and make things much better performing. For example, right now we have a development in Zabbix happening. We are redesigning one page where we had vertical text in table cells in the header. Because of that thing, the version 6, we had to generate each label as a PNG. And there was like tons of hacks to get around the lack of text rotation in MSI 6, lack of PNG transparency and whatnot. So I think our developers spent like a week on getting it working all of the browser versions. Like most of that time was spent on this one. Now it's all like vertical CSS text and very fast, no more image generation, page is much smaller. Everybody benefits by dropping this single thingy. Well, while at that, we also dropped MSI 7 support, but I don't think anybody will cry about that either. So maybe more about the actual features in the Zabbix. So the Zabbix frontend offers the built-in graphing, and if we are monitoring a single value, then this graphing is sort of free. Free in the configuration sense. So you do not have to configure anything to see a graph of a single value, which is pretty great. In the Zabbix frontend, the graphs are generated runtime. We do not have to pre-configure them or pre-generate them. We can change runtime the time period that's used, that's displayed. The time period can be changed with a scroll bar. There's calendar pop-ups where you can choose the beginning, end dates, and times. You can even drag, zoom, and drill down on the graph like this. So it's slightly Ajax-y, shiny there. There's lots more things. For example, this bold line here, that's automatically detected from the problem definition, from the trigger, that the CPU load above 5 would be considered not that great. So it's also displayed on the graph. If Zabbix can figure out what the trigger expression says, because some of them can be very, very complex, and then it will just pretty much ignore them for the graphing purposes. Of course, you can create your own custom graphs, which will allow you to show more than one value on the graph. This one is showing 4 different MySQL query types on a single graph. This system, as we can see, it's not really doing anything here. It's like averaging around, 40 queries per second. But when you're creating custom graphs, you do that in the same web-based frontend. You just click add the items, and it's done. And of course, all that can be templated as well. So you create a graph, and it's available on all the hosts which are assigned to that template. Network maps. This is a very important part because it is one of the most versatile visualization options in Zabbix. So on a map, you can add all kinds of different elements. You can add individual problems, hosts, host groups. You can even include a map inside the map, creating a hierarchical setup. You can show all kind of real-time data. Here I just have city names as labels, but we could show the CPU load or any other thing below each of these systems. One thing we did in a university in Latvia, we started monitoring how many users are using each of their internal systems. So they had they had Moodle, they had some other custom systems, and well, we showed that on the map, which was nice, but maybe even more interesting thing was that we show how it changes over time. And when we had monitored it for a couple of days, we saw that there was a pattern. The user session count started to increase slowly around 6 or 7 o'clock, then there was a bigger jump around 9 o'clock. Then it slowly grew, and then around 12 o'clock there was a big jump. So it stayed up there till around 5 o'clock, there was a slight jump, then till 6, 7, slight drop, 6, 7 dropped a bit more, and then there was a big drop around 12 o'clock, midnight again. Our conclusion was that students don't get up early. So sometimes Zabbix offers really nice insights, or you might expect that, but that was a really hard data showing this as a fact. We can also put labels on links. So this allows to show things like, you can maybe put their text like slow link, but you can also show real-time data like the current traffic, packet loss, latency, jitter, anything you'd like to see on a link. The great thing is that links can also change their color depending on some problem states. You can assign any problem definitions to a link, and then depending on which ones are active, the link might turn yellow for high latency for the colleagues or more often for the management. Technical people are usually okay with some dot which just change the color. But the icon mapping allows you to do this in a more automated fashion. And it really nicely ties in with the automatic inventory collection capability. So what you can do is you can define for each of the inventory fields that it should be matched against a specific regexp. If that is matching, then use this icon. These are sorted by priority. If none of them matches, then there's a fallback icon. So you could have a map, show a bunch of things, automatically gather data about the operating system, and then show a penguin, a window, or I don't know, sun, anything else. Or you could show a corresponding icon depending on the switch vendor. You could show their Cisco, HP, anything else. Another thing that we improved just slightly, but it's a very nice improvement, there's the ability to configure custom scripts for the elements again. So we have two predefined examples, ping and traceroute. You can define your own. We have an example about using nmap to detect the operating system, and there's more things that you could do. But a partner from Austria, they had the problem because they were using Zabbix also as a management interface, and they had defined their several commands. Two of the commands were RPM version, because they had custom software on their workstations, and reboot. Anybody sees any problem with these two entries? RPM version and reboot. They both start with the same letter. So it went something like this. Oh, let me check the So for them, in 2.0, a feature that was implemented allows to define a custom message for any script that you would be executing, and that would show you a message that you are specifying here. It would not be executed until the user actually confirms that. Another visualization option that allows to tie all this together in a really nice advanced fashion is something we call screens. And screens allow you to put on a single page lots of different elements. This is a pretty old screenshot actually, but it shows that you can put lots of them here. It shows graphs only. You can combine here anything. The maps that I was showing parts of briefly before, you could show a large map at the top, some key graphs below that, maybe some raw values below that. Again, no hacking. That is just the question of the configuration. Screen is, you have some time period, the scroll bar at the top of the screen to show, to change what time period will be displayed. So all the graphs on the screen will always display the same time period. You can easily and nicely change that. Even drag and drop, even drag zoom on any of the graphs will work on the whole screen. So here we have a bunch of systems. One row is one host, one column is one type of data, and well, it shows there some temperatures, fun RPMs, CPU loads. So that's a nice overview. What Zabbix partner in Brazil did, they created something for each of their customers with a pretty shiny map showing nice custom icons and then how the customer environment interacted with the central router and everything else. A couple of key graphs showing the customer port throughput and so on. And then they had two external URLs which were showing IP cameras, showing customer servers real time. Fairly useless, I would say, but customers liked it. So even that is very, very easily doable with Zabbix. Well, as long as you have the cameras, of course. And talking about the usability, there's also a development which was finished probably a month ago only. It's already in the latest stable release, and it's 2.03. In previous releases, if you had a screen like this, or maybe even bigger, this is actually from the real screen, this is just a small part. When it would automatically refresh, it would just reload the page. Which meant that if you had a larger amount of the elements there, it would start generating the graphs, and they would just pop up there, and it would just kind of jump up a bit until it stabilizes again. So now it's all more Ajax-y, more modern, so things just flip there without you even noticing that they're updating in the background. This should also reduce the network traffic and slightly reduce the load on the Zabbix server if lots of users are looking at a screen like this. Another new feature in Zabbix 2.0 was ability to define a visible host name. So we have these so-called technical host names, which is how a system is identified, but quite often, especially in large environments, it is identified by something which to another person looks like just a garbage of numbers and letters. It actually means something. There's data center this and this type of servers, but to users, quite often it makes sense to show some more meaningful name like an email server or application server. And these also fully support Unicode, so you're free to use their characters with umlauts or set, or sorry about my pronunciation there. Another built-in feature of Zabbix is direct web monitoring, so you can monitor web pages. This is based on scenarios. They consist of steps, so Zabbix can go to a web page, open this page, and see whether all of them in succession are successful. There are some built-in graphs, so here we can see the speed and response time graphs. You can create your own graphs, you can customize them, so that all is available. Built-in. Now let's talk about the feature which is really, really great. I'm not even sure which is better, LLD or low-level discovery or this one. I probably would vote for this one, and that is dealing with the remote environments. If you're monitoring a remote environment, there's more than one device. The problem is that very often it's not that desirable to have lots of connections to all those devices. You have lots of connections over the wide area network. There's latency, there's increased network load, increased network traffic, and so on. That might be a branch office, maybe another data center, maybe some client side that you're monitoring for them. And of course, there's quite often there's a bigger problem. You just cannot monitor things directly. And the solution that Zabbix offers, the great one, we call that Zabbix proxy. This is something which has been available for quite a long time, actually. And Zabbix proxy is a very, very simple process which is running inside that environment. It's connecting to the Zabbix server, getting information about what it should be doing, and then just goes and does that. Then it has some data, connects to the Zabbix server again, and sends that data. It only uses a single TCP port for the connection to the Zabbix server. Again, it's fully IANA registered. All the configuration is fully centralized, fully on the Zabbix server. So even if you have a larger amount of Zabbix proxies, you do not have to somehow think about distributing the configuration data yourself. The proxy, once it has received the data from the server, the configuration data, it has a local cache for that. And then it can monitor these things even if the connection to the Zabbix server disappears. And if the connection to the Zabbix server disappears, it will also buffer all the gathered values locally in its own database. When the connection is restored, all that data is transmitted back to the Zabbix server, so nothing is lost during the downtime. Zabbix proxies can do pretty much anything that the Zabbix server can do. SNMP, IPMI, agents, incoming, outgoing connections, everything. The great benefit, of course, is that you only need a single TCP port open in a single direction through the firewall. There's smaller amount of network connections being made, and in general, the data is more compact because the proxy sends that as a single batch. What is also very easily to do, the proxy is very simple to set up, very simple to maintain. So you could just pre-configure a proxy, ship it somewhere. On the other end, somebody just plugs it in the network, probably power outlet as well, and that's it. As long as it can communicate with the Zabbix server, all the configuration now can be done centrally from the Zabbix server. Nothing should be done locally anymore. Several years ago, when somebody would come to us and say that they are using the proxies, that was already considered a larger environment. Then somebody came and said they have like 10 proxies, which was like, oh, that's a pretty large environment. Then there was a bank in France with 19 proxies, and we were like, hey, that's really cool. So now it's really changed in the last few years in this regard. For example, I recently talked to a person. They are monitoring digital cinemas all over the world, and they have one Zabbix proxy in each location, and they are actually using around 1,000 Zabbix proxies without any issues at all. And the great thing is that that's not the biggest environment with the Zabbix proxies. The most interesting environment regarding the proxies and distributed monitoring with Zabbix is coming from Uruguay, where they have the one of the world's biggest OLPC deployments, the one laptop per child program. They have distributed close to 500,000 free laptops to school children, and they're providing free Wi-Fi to these laptops in various locations, schools, libraries, whatnot. And they'd like to monitor each of these locations. So they evaluated all kind of solutions, and they chose Zabbix because of the proxies. Because in those remote locations, network might be down for maybe even a day, and they'd like to put a proxy there, monitor the access points, maybe a server or two, so that each location is relatively small. And when I last talked to them, I was asking them, so how it's going, how many proxies do you have? And they were like, well, 2,500. Like, my first question was, and it works? And they just said yes. They're using a single Zabbix server running on top of MySQL, nothing really fancy, and 2,500 Zabbix proxies scaled for them without any customization, any specific configuration at all. When I told this to Zabbix developers, they were, I don't think they believed me at first, because they were like, no way. But given that a bit later we found out about another installation which also was in thousands, then that seems to be not so hard to do actually. And of course, Zabbix proxy can also operate in the other way around. This is called the passive proxy. So if you'd like to put the proxy in a DMZ, you wouldn't really want the proxy to connect to the internal network where the Zabbix server might be located. So the Zabbix server can connect to the Zabbix proxy, send the configuration data, proxy now does things, and then just server connects to the proxy periodically and asks for the data. There's another great thing is that proxy can really run on low hardware requirements. So people are running it on all kind of the PC Engine's Alex platform boards, on the Raspberry Pis, of course, on Soecris devices. It's really nice in this regard. And of course, all kind of routers, especially with OpenVRT or other Linux distributions on them. And tying in Zabbix proxies and new features. And then the feature that I talked about before, that is the web monitoring. Of course, you can monitor the web pages directly using the Zabbix server. But before Zabbix 2.0, that was the only way how you could monitor the web pages. Starting with Zabbix 2.0, you can also monitor web pages over the proxy, which can be either the active proxy or the passive proxy. So it's possible to monitor the same web page from multiple locations or multiple web pages from different aspects and angles and network locations. Anybody here using Java application servers? Some 10 people, maybe a bit more. So that's it's an aspect of how you monitor different Java thingies. And at least with Zabbix previously, there were several solutions. One was a third-party add-in called Zapcat, which you could deploy on your Java application servers. It provided native Zabbix agent interface. Another solution was to script something on the Zabbix server which did not require deploying anything on the servers, but was a bit hackish. Maybe wouldn't perform that well if we were talking about a lot of data. So it was possible, but it wasn't maybe that great. Now it's great and easy. Because since Zabbix 2.0, there is something called Zabbix Java Gateway. This is a process which is sort of proxying Zabbix server requests. Then it's connecting to the JMX interface of any Java application. That can be a classic Java application server. That can be any Java application as well, as long as it's configured to expose JMX. So you can monitor the heap space, garbage collectors, everything for any Java application, even if it's a desktop application like some client or anything. The Java Gateway, it's not like an hardware appliance or something. It's just a process, a daemon. So it can run either on the same system where the Zabbix server is running, or it can run on a completely separate system for management, performance, or any other reasons. It's really easy to set up. Personally, I managed to do that successfully the first time I tried. So here's a very simple graph. I tried test installation of OpenFire. OpenFire is a messaging server. It supports Jabber or XMPP protocols, all kind of other thingies. So I just set up OpenFire. It didn't do anything. It was just running. And I monitored its heap memory usage. So turned out that it was increasing over time. So here it's like some 24, 25 days, and it was just constantly going up. I have no idea why, but to me it looks a bit suspicious. But I didn't really pursue that much. On the other hand, I went in a bit of a loop and I monitored the heap memory usage of the Zabbix Java Gateway itself. That one turned out to be a bit better, and it didn't really go up. Another thing, you can see that even the Java components of Zabbix are very efficient. The heap memory usage of Zabbix Java Gateway, okay, admittedly it's monitoring only 2 items, but that was around 2 megs of memory. Pretty decent. And of course, you can use direct monitoring, like Zabbix server asks the Zabbix Java gateway, it asks the Java application server, and you can also do that through the proxy for remote environments. Either passive proxies, active proxies, does not matter, it will work the same way. So you can really spread this out in the larger environments. A bit more about the extendability of Zabbix, because this is a very, very important part. Lots of users like it, especially in large environments, because they probably have different custom applications. And Zabbix agent is very easy to extend. You can add all kind of custom data that the Zabbix agent should be collecting and should be providing to Zabbix server or Zabbix proxy. We'll see in the next talk after lunch about the extending NetSNMP. Personally, I would say Zabbix agent is a bit easier to extend than NetSNMP daemon. But maybe I've just done that a bit too much, but I can show that later if anybody would like to test this claim. This extendability of Zabbix is very, very popular in financial institutions because they seem to be having lots of in-house different specific environments. Then you can also run any command in response to events. So if you like to use the built-in methods like email, SMS, you can do that. If that doesn't suit you, you can just automatically open tickets by integrating with some API or anything else. A very, very awesome thing is a small command line utility called Zabbix Sender. It allows you to provide data to Zabbix in a custom format. And you can feed any data to Zabbix, which is very useful for if you have some high rate generating application, or maybe you would like to integrate historical data in Zabbix. So you can also feed already timestamp data, and it will be automatically calculated, put in the correct locations, graphs will be available, and everything. And of course, your system, your language. Perl, Ruby, Python, Shell, PHP, I don't know, Haskell, whatever. That's up to you. Talking about the scalability, this is a very important aspect, especially in the last few years. Zabbix is being adopted by bigger and bigger organizations. Zabbix daemons, server, proxy, and agent, they are written in C, so they should be fairly efficient. Talking about the server, we have reports, and we also know some users which are monitoring up to 40, 80,000 of hosts. There are reports of more, but unfortunately, as with open source software, in many cases, I'm communicating with people running these environments, but they are not even telling me which organization that is. So I have some guesses about some of them, but that's about it. Talking about the scalability and processing, Zabbix server is able to process thousands of values every second. So we are calculating how many values server can process per second. And some years ago, again, that was very uncommon to have somebody collecting about 3,000, 4,000 new values per second. Now we have several customers like that. And if we would translate that in something like maybe more similar language to this environment, let's say checks which are done every 5 minutes, and now correct me if that's wrong, but that translates to more than 2 million checks every 5 minutes. That is done with a single Zabbix server, no customizations, no patching, no custom, I don't know, components. That's just the out-of-the-box vanilla Zabbix server. Of course, that is not out of the box, you know, the desktop running that, the hardware. That's there's some disk array there, there's some database tuning done to achieve that, but it's doable. How this is achieved, that's mostly done with quite a lot of very efficient caching. Zabbix developers are constantly improving performance by improving caching, by improving database access, reducing the database query count, and that's really a very, very important part of what the development team does. The proxy scaling, we already talked about the proxy, so actually what most people do with the proxy scaling, they just spin up another one. It's very easy to do, and they don't really bother with trying to push the last juice out of the single proxy box. Nevertheless, the development team recently improved the proxy performance as well, again, by introducing another caching layers in the proxies themselves. Talking about constant improvements, Tita 2, the upcoming release, again, this is something I can promise because this development work was done, finished this week, again. And Zabbix has all kind of internal processes. You can configure how many of these. Like the Polar processes are connecting to agents, to SNMP devices, gathering data. By default, there's like 5 of them. You can go up to 1,000 for huge environments and so on. And there are also internal processes calculating some conditions. They're called timers. And previously, we had only one timer process, which was doing the calculation of things which check that data is missing for some period of time. They were firing every 30 seconds. So of course, when we're talking about systems with dozens of thousands of monitored hosts, it could be very, very busy. In 2.2, you can just configure the amount of timer processes, and you can scale out to how many cores you can just give to Zabbix. If anybody would like to know more about the internals of the Zabbix, feel free to come to me later. I can show you there's like some 18 or more internal processes in the Zabbix server alone. Agent scalability and agent usability, maybe let's say the smallness of the agent. A recent experiment I did, well, just a very simple one, excluding the shared libraries on a 64-bit system, the native Zabbix agent on Linux was using 736 kilobytes of RAM. Probably could be less, there might be some tricks there, but I think that's pretty decent for a full-blown monitoring agent. That's a daemon, which is also doing all kind of calculation in the memory. So it's not just the daemon code itself, it's also different buffers there. Yep, so Zabbix server is constantly being improved performance-wise. Caching, that's our last, like the magic of the last few years. And I already mentioned that we are reducing the database access for the server. Proxy, there's something that's still planned, and the idea is to somehow make the proxy send more than 1,000 values, well, every half a second or so. Currently, there's a bit of like latency or threshold involved, sorry, the limit involved there. So this is something our developers are trying to figure out how to best push the data through the network layer at this point already. And with some databases, Zabbix proxy would stop operating if you would be running it nonstop for years. Now it's fixed. Now you can run Zabbix proxy for a really long time. Zabbix agent, talking about the memory. Previously, Zabbix agent was limited to monitoring 8 disk devices, and it would allocate memory for all of them right on the startup. Now, Zabbix agent will allocate the memory according to how many devices you have, how many disks. So if you are not monitoring any disks, you're running on some router device where every kilobyte is important, that will shave off several 100,000 kilobytes more of the memory usage. But if you're monitoring some 1,000 disks, now that is supported as well. We had customers with lots of physical disks, and 8 was not really enough for them. A few more things about the enterprise and the compatibility. Database, so Zabbix, database for Zabbix is very important. In one major release, database is not changed. So you can upgrade inside one major release very easily, very quickly. We support all the old agents with the latest server. So if you're running 2.0 server, you can still run 10-year-old 1.0 agents. So we still have banks actually doing that, and it's fully supported as long as you don't need the new features in the agent. Again, some promise in 2.2, the next version. Currently, you have to patch the database manually using an SQL patch. In 2.2, this will happen automatically by the Zabbix server. So maintenance will be easier as well, finally. Few quick words about the popularity of Zabbix, how it's growing, how it's improving. Of course, I mentioned Japan. Our partner in Japan is NTT Communications or Technology Communications. I think they recently slightly rebranded that part. And in Japan, they have Zabbix user workshops where they regularly meet, and there's like 100 users talking about Zabbix, and it's really, really surprising to me. Sectors, financial sector probably is the one where Zabbix is the most important, the most popular. If you would look at the biggest world's financial organizations, and you could just point at most of them and then well, claim something probably. And it's also very, very rewarding when other open source projects appreciate what Zabbix is doing. Anybody knows what KDE is? I would expect in this country to know that better than in others, maybe. But KDE is one of the most popular open source desktop environments, and their public monitoring interface looks like this. It's the serverstats.kde.org. And when they have some problems, they will just show the problem, whether there were any acknowledgements done, and so on. That doesn't look like Zabbix. Because that is their own custom frontend, which is written against the Zabbix API. They wanted to have something extremely simple for public viewing, and this is what they came up with. When they do not have any problems, they show this. Very simple. And I'm already on the finish line. Just a few words about the uncommon usages of Zabbix. These examples actually date back from 2011. I first came up with most of them in the first Zabbix conference in Riga. One is that we are monitoring the amount of the users in the Zabbix IRC channel on Freenode. It's #Zabbix. So that shows both the extendability of Zabbix, and it also shows that you can generate almost 6.5-year long graph in Zabbix in well, here it says 0.33 seconds, but that kind of jumps up and down. This is a bit slow and low resource restricted virtual machine actually running this. And the Zabbix user count on the IRC is really growing a lot. When we met here 2 years ago, we were somewhere around here, which is around like what 90 users in the IRC. Now we are approaching 200 users, so we have doubled the user count in IRC in 2 years, which is pretty nice. And feel free to come there, ask about Zabbix. Don't expect to have answer like in 5 seconds. That's the instant messaging part. Wait a bit, but our IRC channel members are fairly mature, very friendly, and knowledgeable as well. The dips here, those are net splits, of course, here. So that's very simple. This is coming from a Zabbix server developer, and he was monitoring temperature, which seems to be simple and common thing. Everybody's monitoring temperature one way or another. But this was a weather forecast, not an actual temperature sensor. So he had an alert saying like, this will be very cold, bring some clothing, or it will be raining, bring an umbrella, or it will be very hot, I don't know, move very slowly. So here we can see around 1 year data. As we see, the winter was pretty mild. There was just one drop to -25 or so. Summer was unbearably hot, going up to some 30 or so. Interestingly, that straight lines that's the missing data. And one of them appropriately was this box being hit by a lightning. No warning on that. This one here also shows the flexibility of Zabbix, and it's a bit older. We by now have more, but these are Zabbix translations. So we are monitoring using gettext, and we are monitoring the untranslated fuzzy, there's very little of them, and the translated strings. So the untranslated is red, translated is green. As you can see, it's fluctuating. Now it's actually better because we are helping our translators more. We have introduced string freeze finally, so it kind of motivates them a bit. And just in the last month, we had 3 new translations, including Finnish, Persian, and Indonesian. And so that's all growing as well. Another uncommon use was a user monitoring how the OpenStreetMap project changed its license, which was a bit of a geek drama there. But he was doing this, and you could see how it's fluctuating, it's growing, and so on. And it seems like there's lots of disagreement, and it's not that much compared to the agreement. When you look at the scales, actually, disagreement is here, agreement is there. So it's like 70K versus 400 or so. So it's actually a large difference. And the last uncommon thing was that a year or more ago, I was contacted by a user from Hamburg, and he was saying me that one of his colleagues has found out a serious bug in Zabbix, and then he sent me this graph. Just in case, the green and blue, that's the actual Zabbix graph, right? So that was done by Zabbix. The rest, it's a bit harder. So our main weapon is, or our 3 main things that I'd like to remember you to remember about Zabbix. That Zabbix is extremely flexible and adaptable to almost any environment. It's very scalable and performing well, and it's very rapidly improved. As you saw over these 2 years, I was just showing the most important features. And as I said, 3 main features. Of course, it's true open source solution. So please visit the Zabbix website. If you cannot find the information there, there's also a blog with maybe some more rapid information, and everybody is really welcome on the IRC. And I think now everybody is ready for lunch, but maybe you have questions as well. Thank you.